multiply both sides by negative 1. If I multiply both sides by negative 1, I see that I get negative 2x first. Negative 1 times negative 3y is positive 3y. And negative 1 times, what is that number? Times negative 5 is positive 5. And now what I do is I look at, I don't look at the first equation anymore because I changed it. I look at what I changed it into. So now I'm looking at this equation and this equation, highlighted in green. And just like I did in number 3, I add those two equations together. When I add those two equations together, what happens to the x's? They cancel each other out. They eliminate it. They're gone. So now I have negative 4y plus positive 3y for a total of negative 1y. And on the right side of the equation, I have negative 4 plus positive 5, which is positive 1. That means that my y value has to be negative 1. Because I divide both sides by negative 1. Oh look, I have my y value. Now I just need to find my x. I have 3 equations. Which one should I plug it into? Any of them. Doesn't matter. Don't care. Pick one. I'm going to pick, okay, the second one. So I'm going to shove this number into the second equation wherever I see a y value. So I look at the second equation and it says, oh, I've got 2x minus 3 times whatever my y value was. That y value was a negative 1. And when I do that, that should be equal to negative 4. That's looking at the second equation. I could have picked any of them. Okay, so we just observed that it should have been negative 4 here. So we'll erase that. Thank you. So it's 2x minus 4 times that negative 1 value. Good catch. Second equation. And now I simplify that equation. And when I simplify it, I've got 2x plus 4, because negative 4 times negative 1 is positive 4. And that's equal to negative 4. Oh no, I have a positive 4 on the left. I get rid of that positive 4 by subtracting 4 from both sides. So now I have 2x equals negative 8. Because negative 4 plus 4 is 0, but negative 4 plus negative 4 is negative 8. And when I solve that, and I get my final answer, I divide by 2 and get x equals negative 4. Number 5. In number 5, notice how none of the x's or y's are the same number. But I do notice that as I look at the y's, one's positive and one's negative. You guys see that? It sure would be nice if that 2y that's negative would have been a negative 6y, because then they would cancel out. Nick? Okay, tell me. Multiply by 3. I like it. So I'm going to take that first equation and I'm going to multiply both sides by 3. When I do that, the first equation will be the same equation but looking different. So 3 times 4x, that's 12x. 3 times minus 2y, that's minus 6y. 3 times negative 2 is negative 6. And now what I've done is I've changed the first equation so that when I look at my original second and my altered first, I notice that the y's are the same number but a different sign. And now I'm set up to add those second two equations. When I add the second two equations, the second and the third I should say now, 8x and 12x makes 20x. Negative 6y and positive 6y disappear. And 31 and negative 6 together is 25. Nice, they give us some decimals again. We love that. Divide both sides by 20, and x is equal to 25 divided by 20. Or you could write that as 1.25. I'm now missing my y. I can pick any of the three equations. I tend to stick with the smaller equations if I can. So I would pick the first or the second equation and not the third. But it doesn't matter. You can pick any of them. Which one would you like to pick? First. Okay, so let's look at the first. I'm going to go up to the first and I'm going to plug the 1.25 in wherever I see that x value. So now I have 4 times whatever the x was, which we just found out was 1 1/4 or 5/4 or 1.25, minus 2 times y, and that equals -2. When I multiply the 4 times 1 1/4, I get 5. And I still have my minus 2y. And that's still equal to a -2. How do I get rid of the 5? Do what?
Add 2y.
Subtract 5 is the correct answer. So I subtract 5 from the left. Whoop, gone. Only 2y that's negative left over. Subtract 5 from the right, and I get -7. Then you divide by 2. That's negative. Divide by -2, that is. And you get 7/2. Or if you like, you can write that as 3.5. And again, this is talking about you're crossing these two lines at 1.25, comma 3.5. Wow, look at number 6. Not only are the numbers not the same, but now you have to figure out which one you want to get rid of first. So we look at those, and I notice that not the x's, I should say, excuse me, are positive and negative. That's good. The y's are positive and negative. That's good. I can choose either variable. So we pick one of the two variables. It doesn't really matter. Which one should we get rid of?
6.
Which variable?
Oh, y.
Okay, let's get rid of the y's. That means that I'm looking for a number that I can turn 16 into and I can turn 6 into. Both. Can I turn them both into the number 30? No. Not by multiplying by an integer. Can I turn them into a 10? No. Can I turn the 6 into a 16? No. What number can I turn both of them into? So we're going to turn the y's both into 48. The way that I'm going to do that is I'm going to take the top equation and I'm going to multiply everything in that top equation by 3. If I do that, I get 18x minus 48y equals 90. But then in the bottom, I have to multiply by something different. I have to multiply the bottom equation by 8 in order to make that happen and turn it into a 48. So 8 times -15 is -120. Wow. -120x. And 8 times 6y is positive 48y. And 8 times -75 is negative
600.
600? Holy mackerel. These are ridiculous numbers. And now I'm not going to look at the first two equations anymore. I'm only going to look at these two equations that I produced. And I'm going to add up those two equations. So as I add up those two equations, what I see is I have 18 positive and 120 negative x for a total of negative 102x. And then on the right side, I have positive 90 and negative 600 for a total of negative 510.
Yeah.
And now to find my answer for x, I divide both sides by negative 102. And I find out that x is equal to 5. So it looked really crazy, but in the end, the number came out to be something kind of nice, I guess. A whole number, an integer. Now this x that I just found, I'm going to put in one of the equations. It does not matter which equation you put it into. Doesn't matter. So you pick which one you want to shove it into. Let's say we put it in the first equation. Doesn't really matter. So as I put this into the first equation, what I will see is I will see 6 times whatever the x value was, which we just found was a 5. And then I have minus 16y, and that equals 30. When I simplify that, I find out that I have 30 minus 16y equals 30. What next? Subtract 30. So I subtract 30 from both sides, and something weird happens. I get 16y, which is negative, equals 0. But to solve for the y, you're going to divide both sides by the negative 16, and you find out that y is still 0. So your x is 5, and your y is 0. In number 7, I see two equations, and I'm going to try and pick one of the letters, and unfortunately, neither of these variables have one positive and one negative, and neither of the variables are equal to each other. So what I'm going to do is I'm going to pick one of the equations, and not only am I going to turn the numbers into each other, but I'm going to make one of them the opposite of what I see. So I'm going to choose to get rid of the x's. If I choose to get rid of the x's, that means that I would have to multiply the top equation by, close, negative 6. Because if you multiply by 6, you would get 12x, and that doesn't get rid of the x's. So when I multiply it by negative 6, I get negative 12x, negative 18y, and negative 24. And now I'm only going to be looking at the second and the third equation, because I changed that first one. In order to eliminate, we had to multiply them so that one was positive and one was negative, and now I add those up. The x's cancel out, the y's cancel out, and I get 0 equals 2. What you notice is that this is a ridiculous statement. 0 does not equal 2. This is what they call a false statement. Whenever this happens, the reason this is happening is because these two lines are parallel, which means they never cross. In number 8, I'm going to do the same thing. This time, let's say I choose to get rid of the y. In the first equation, I'm going to multiply by negative 5. If I multiply by negative 5, that equation becomes negative 10x minus 15y equals negative 90. I add those two equations together. That is, I'm adding the second and the third equation together. And what I see when I add those two equations is 0 equals 0. Notice how in this case we have two numbers that are equal to each other, and it's a true statement. This only occurs when these two equations are exactly the same line. So they're intersecting everywhere. They lay right on top of each other. So whenever you see two numbers that don't equal each other, lines are parallel. If they equal each other, same line.